Good evening. I'd like to thank y'all for this opportunity to be here and present my master's work. I'll be presenting on the assessment of stockpiling methods to increase late summer and early fall forage biomass. This is the outline of my presentation. This is what I plan to cover and the order in which I plan to cover each topic. So for this experiment, we used tall fescue, and as many of you know, tall fescue is one of the most persistent and widespread grasses in the eastern United States. It also has many positive characteristics, even though we've heard much about the negative. And some of these positive characteristics include a long grazing season, tolerance to environmental stress, and pest resistance. But it does have some drawbacks, one of which is the fact that it exhibits a cool season growth pattern. And this leaves us with decreased forage availability in both the winter and the summer months. So one of the strategies that we have to deal with this decreased forage availability during the winter months is the practice of fall stockpiling, which is just simply holding over the fall growth for grazing or utilization later in the winter months. So in this experiment, what we plan to do was to use the same basic method for summer stockpiling and to hold over the spring growth for utilization in late summer and early fall. So the objective of this experiment was to assess the effect of summer stockpiling endophyte-infected Kentucky 31 tall fescue on the biomass yield and nutritive value of the tall fescue forage. This experiment was conducted in 2011 and 2012 at the Shenandoah Valley Agriculture Research and Extension Center located in Steele's Tavern, Virginia. We had 6 replications in a split plot design with 4 whole plot treatments. These 4 whole plot treatments were different fertilization treatments. There was a control, a legume inclusion treatment, and a March nitrogen application treatment, as well as a May nitrogen application treatment. The legume inclusion treatment was the frost seeding of red and ladino clover into these plots in February of 2011. For each of the nitrogen applications, it was a single application of nitrogen in the respective months, and nitrogen was applied in the form of urea at the rate of 50 pounds per acre. Now, each of these different fertilization treatments was then split into a cut and a no-cut treatment. And the cut treatment was meant to simulate a hay cutting that would be taken in May. Within each replication, the fertilization treatments were randomized. However, the cutting treatments were not. So for each replication, the no-cut treatment always remained on the top half of each replication, and the cut treatment always remained on the bottom half. There were 2 sampling dates, one in May prior to the hay cutting, and the other one in August. At each sampling date, a 2.69 foot square quadrat was collected from each treatment for biomass yield assessment, and grab samples were collected for nutritive value analysis. These results for the yield, I will be presenting a use variable. Now, this use variable represents the total amount of forage that is available to the producers for use at the end of the period that we were looking at, which would be around the end of August. So for the no-cut plots, use was simply equal to the total amount of forage that was available in the field to be grazed in August. For the cut plots, it gets a little more complicated because remember, we took a hay cutting in May. So we not only had the hay that could be utilized, but we could also graze the regrowth. So the hay yield we based off the May sampling, and then the regrowth was the August sampling. Nutritive value for both the cut and the no-cut plots, those results were based off of the August sampling, and so that's just the nutritive value of the forage that's available in the field to be grazed in August. So moving on to some of the results. For use, you can see on the y-axis we have the average yield in tons per acre, and we had an effect of fertilization with the March nitrogen application having a significantly higher yield than the control. We also had a year by cut interaction. Again, we have average yield in tons per acre on the y-axis. You can see within the year of 2011, we have a significant difference between the cut and the no-cut plots. And also within the year of 2012, there's a significant difference between the cut and the no-cut plots. However, in 2011, the cut plots had the highest yield, but in 2012, the no-cut plots had the highest yield. We attribute this to the fact that in 2011, we had a higher hay yield. So as you can see from these photos, hopefully, in 2011, the tall fescue forage was much taller. Our hay yield in 2011 was approximately twice that of what it was in 2012. And as you can see from the 2012 photograph, the hay yield was much lower, the grass was much shorter that year. Moving on to some of the nutritive value data. Here we have percent neutral detergent fiber on the y-axis. We had an effect of cut as well as a year-by-cut interaction. You can see that within 2011, the cut and the no-cut treatments were significantly different from each other. And within 2012, the cut and the no-cut treatments were also significantly different. The cut treatment in 2011 exhibited the lowest overall NDF level. For percent acid detergent fiber, we had a significant effect of cut year and a year-by-cut interaction as well. Within 2011, we had a significant difference between the cut and the no-cut plots. And within 2012, we also had a significant difference between the cut and the no-cut plots. As you can see, in 2011, again, the cut plot treatment had the lowest overall ADF level. Now, although the no-cut plots exhibited a higher fiber content in both years, you can see from this photograph that cattle would still graze the no-cut plots as well as the cut plots. Moving on to percent crude protein, we had an effect of fertilization with the May nitrogen application having a significantly higher crude protein level than either the control or the legume treatments. We also had an effect of cut year and a year-by-cut interaction. Within 2011, you can see that the cut and the no-cut plots were significantly different from each other. And within 2012, the cut and the no-cut were significantly different. However, there was some similarity across year. We had an effect of fertilization by year interaction. So within the year of 2011, we did not observe an effect of the fertilization treatment. None of the fertilization treatments were significantly different from each other. However, within 2012, we did observe a fertilization treatment effect with both the March and the May nitrogen application treatments having a significantly higher crude protein content than either the control or the legume treatments. So, summary and conclusions. The effect of cutting varied by year. Within 2011, we saw that the cut plots had a higher yield, but within 2012, the no-cut plots had a higher yield. Cutting treatment had a lower NDF and ADF level, but this effect was mixed when it came to crude protein. A March nitrogen application increased yield above the control, but the effect of nitrogen on nutritive value varied by year. In 2011, we did not see an effect of applying nitrogen, but in 2012, both the March and the May nitrogen applications exhibited significantly higher crude protein levels than either the control or the legume treatments. Fertilization did not affect either NDF or ADF levels. So we really need further research to determine whether this effect of nitrogen will hold true in subsequent years. But right now, what we can say is that the best method for summer stockpiling will actually vary depending on the year. So with that, I'll entertain any questions. Yes, sir. Okay, so the question was, how do these results compare to the literature review? Because the crude protein levels seem to be much higher than you would expect for forage that has been growing all season. Yes, the forage did exhibit higher crude protein levels than what one would expect. However, I do want to point out that this was existing tall fescue pasture. So although it was predominantly tall fescue forage, there were some other grass species mixed in. There was a little bit of orchard grass as well as some Kentucky bluegrass. So I think that probably contributed to the effect that we've seen with the crude protein levels and the fiber content as well. Yes? So the question was, did I separate out the legumes? That's a very interesting question. We were planning to. However, we saw that although the clover did establish, I did do seedling counts to prove that the clover did establish in these plots. When the grass got up, by the time that we actually went to sample, although with the May sampling, the clover was present, it wasn't at the 4-inch grazing height that we were collecting, so we didn't actually collect clover in the samples. If we had have collected clover in the biomass samples, then they would have been hand separated and weighed separately, so we could have assessed the clover component. But we did not actually get those in the samples that we collected. Okay. Okay, so the question is to talk about the grazing pattern and behavior between the cut and the no-cut plots. So I'll take you back to this picture. This was part of a larger field, so when this was grazed, it was strip grazed as a part of a larger field, so we couldn't actually separate off the cut and the no-cut plots. So they were allowed access to both at the same time. However, there was more trampling with the no-cut plots. They did eat it. You could see where they grazed it, and as you can see from the picture, they are grazing it. With the cut plots, especially in 2011, the cattle grazed those much lower, which would be very conducive if you were wanting to go into a fall stockpiling situation. But yes, there was some difference in the grazing behavior.
Thank you very much.